All right, so we're going to go over a couple types of factoring. The first one is common factoring, or finding the greatest common factor. Okay, so that's basically just looking at all your terms to see what is in every single term. So let's look at some examples. So here we have x squared plus x. So there's at least one x in each term. So what we can do is pull out that x and call it the greatest common factor. And then we have to put a bracket and just ask x times what gives us x squared. So x times x gives us x squared. And then plus, so we have our plus, x times what gives us x. So that's just 1. Okay, so this is pulling out a common factor. It might not be a variable. We might pull out a coefficient. For example, here we have 2x minus 8. So in this case, the greatest common factor is a 2, because that's the largest number that can go both into 2 and 8. Okay, and then 2 times x gives us 2x, and 2 times negative 4 gives us negative 8. All right, trying a more tricky one. Let me just skip. Let's go down to f. So if we were to look at this one, we could have a coefficient. So we have 4, 6, and 2. So it looks like 2 is the greatest common factor there. If we look at the variables, we have 2 variables, a and b. This one's a cubed, a squared, and a. So the lowest is just a. There's at least an a in every single term. And the same for b. There's at least a b in every single term. So that's our greatest common factor. And then we need to multiply this through to make sure we get the same thing. So 2 times 2 gives us 4. A times a squared gives us a cubed. Because remember, if you're multiplying similar variables, the same variable, you add the exponents. And finally, b times b cubed gives us b to the power of 4. For the next one, 2 times minus 3 gives us minus 6. And then a times a gives us a squared. And then b times b gives us b. And I'm sort of running out of room. One eraser. Nope, I have one. And for our last term, right? Our last term is the exact same, 2ab and 2ab, so 2ab multiplied by 1 would give you 2ab. So that's pulling out your greatest common factor. I'm just going to do this last example here, because this one's interesting. Notice that the greatest common factor is the bracket in each term. So we can actually just pull out that bracket as 2x plus 1. And then we're going to throw another bracket here. And so in the first term, we have 2x plus 1 multiplied by x. So I'm going to have that x here. In the second term, 2x plus 1 is multiplied by negative 2. So I'm going to have the negative 2 there. Okay, so I'm going to pause the video, and I want you to try C, D, and E. And if you have any questions, please ask. All right, so factoring simple trinomials. Let's first look at 2 binomials. And we're going to expand and simplify. So to do that, we're going to use the distributive property. Right, so x times x gives us x squared. X times 5 gives us 5x. And then 3 times x gives us 3x. And then 3 times 5 gives us 15. Now here are some common terms, or like terms. So we can add them. So we have x squared plus 8x plus 15. Now notice when we have this, here's our trinomial. And we say it's a simple trinomial because our coefficient in front of the x is a 1. So in this equation here, where a equals 1, that's going to be a simple trinomial. Right? And in a simple trinomial, we notice that the second term, the coefficient 8 is just the sum of these two numbers, 5 and 3. And 15, the constant at the end, is just the multiple of those two numbers, 5 and 3. So if we're looking at this trinomial and we want to factor it, meaning we want to put it into two binomials that are multiplying by each other, we need to ask ourselves what two numbers, to put here and here, will multiply to give you 10 and add to give you 7. You might have to think of this and try a couple of examples in your head. So start with two numbers that multiply to give you 10. Maybe 10 and 1. They multiply to give you 10, but do they add to give you 7? Well, 10 and 1 would give you 11, so no. How about 5 and 2? 5 and 2 multiply to give you 10, and they also add to give you 7, so that actually works. So we're going to put a 5 and a 2 here, and then we'll put our constant, not our constant, our variable out in front there. So that's how you would factor a simple trinomial. Okay, so I'm going to give you 5 minutes or so, and I want you to try expanding and simplifying B and C here and factoring these two trinomials here. Let me know if you have a question. All right, so now we're going to move on to the next page. This is another type of factoring called factoring by grouping. Move the page down here. So when we factor by grouping, what we actually do is we take a group. So here we have 4 terms, but I'm going to sort of essentially group these terms like this. And in each group, I'm going to find a common factor, and I'm going to pull out that common factor. So for the first one, it looks like the greatest common factor is x squared. So I'm going to pull out an x squared, okay, and then I'm going to multiply that by x and minus 4. Okay, because x squared times x gives you x cubed, and x squared times negative 4 gives us our minus 4x squared. Then we're going to do the same thing here. We're going to find the greatest common factor. And in this case, it looks like 3 is the greatest common factor. And then in our bracket, we are going to have x minus 4. Now when you do this, notice that now both brackets are identical. So if we're looking at these two terms now, we can see that we have a greatest common factor between these two terms, and we can pull out that x minus 4. And then that x minus 4 is multiplied by x squared and a positive 3. Right? And there we factored that one. Okay, let me do another example. I'll do C with you. Okay, now C, here's one, here's the other. I'm going to keep that negative there, so we need to pay attention to that negative. But first, let's do the first bracket. So it looks like 3 is definitely a common factor, and also x cubed. So there's our greatest common factor. And when we pull that out, inside the bracket, we'll have x squared minus 2, because negative 2 times positive 3 gives us our negative 6. Now it's very important over here in this bracket, we need to have x squared minus 2. Now in this case, it almost looks like there is no greatest common factor. But even if you think there is no greatest common factor, you can use 1. And 1 is perfectly fine to use as a common factor. Now, because we have this negative here, if I forget about it and I put positive 1, then inside the bracket, I'm left with minus x squared plus 2. And now these two brackets are not the same. So what I'm going to do, instead of pulling out a positive 1, I'm going to pull out a negative 1. And when I do that, the signs inside the bracket have to change, because negative 1 times positive x squared gives us our negative x squared. And negative 1 times, I have to change this sign too, times negative 2, a double negative, gives us a positive. And now we have x squared minus 2 and x squared minus 2. So the brackets are identical. We can pull out that bracket as a common factor, multiplying it by our first term, 3x squared, x cubed, and our second term, which is now negative 1. Okay, so try B and D, and let me know if you have a question. All right, so I'm going to explain this one again. So first, before we factor by grouping, we're going to consider each bracket to be a simple trinomial. Okay, for the second bracket, you need two numbers that multiply to give you positive 9 and add to give you minus 6. So in this case, minus 3 and minus 3. The double negative multiplies to give you positive, and 3 times 3 is 9, and then they add to give you minus 6. So we can factor this simple trinomial into x minus 3 and x minus 3. This one is a special one. It's called it's called a difference of squares, and we'll talk about that tomorrow. But for now, what we can do is think of it as x squared and just add a plus 0x. Again, adding 0 doesn't change anything. And then subtract 9. So now we need to ask ourselves, what two numbers multiply to give negative 9 and add to give a 0? Okay, so in this case, plus 3 and minus 3. Okay, a negative and a positive gives you a negative. 3 times 3 is 9. And also when you add them, negative 3 plus 3, they add to 0. So this is our factor for this trinomial. Well, that's a binomial, but for this this term, and this is our factor for these. And when we do that, we notice there's an x minus 3 in each term. So we can now pull that out as a common factor. And when we do that, we're left with x minus 3. For the first term, we need to multiply it by x plus 3, and then also plus the next term, x minus 3. Now in this big bracket, we can simplify it a little further, because 3 minus 3 is 0, so those are just going to go away. And x plus x gives us 2x. So that was a tricky one. Okay, moving on, here's some more simple trinomials that we'll get back to. But we've practiced those ones. What I want to try is on the next page, which is the last thing I'll do for today, is factoring tricky trinomials. A tricky trinomial is just an example where that first term, the coefficient a, does not equal 1. Maybe it equals 2 or 6 or 12. Okay, it's something else. It's not as easy to think about it in your head. You can't just say what two numbers multiply to give you one thing and add to give you another. So what we're going to do, you may or may not remember this, but we're going to use something called decomposition. Okay, so let's go over this. I'm recording so you can rewatch this because decomposition is a bit tricky. But first, let's look at the coefficients on the first and last term, 2 and 12. If we multiply 2 times 12, we get 24. Now what we need to do is we need two numbers, okay, that multiply to give us 24 and add to give us that middle coefficient, 11. So you can think about that. So what two numbers multiply to give us 24 and add to give us 11? You can try a couple examples in your head. Maybe 12 and 2, they multiply to give you 24, but they add to give you 14. So try another. 8 and 3. 8 and 3 multiply to give you 24. Right? So 8 times 3 equals 24. And in this case, 8 plus 3 equals 11. So that's great. Those are the two numbers we're looking for, 8 and 3. Now that we have these two numbers, we're going to go back to this equation. And what we're going to do is sort of expand that middle term. Now 2x squared we're going to leave, and our last term 12 we're going to leave. But instead of writing 11x, we're going to write it as 8x plus 3x, because 8 plus 3 equals 11. So we're sort of just expanding this. So plus 8x and plus 3x. Now that's the tricky part. Now, when you look at this, it looks like the questions we've just been doing, where we factor by grouping. So if we factor by grouping, we can take this group and we can take this group. Pull out a common factor for each. So the first one, for the coefficients, we have 2. And for the variables, we have at least an x in every term. So we're going to pull out a 2x, and that'll be multiplied into first x and plus 4. Our second term, we don't have an x in both terms, but we do have a factor of 3, so we can do a plus 3. Right? And that leaves us with, again, x and plus 4, because 3 times 4 gives us 12. And there is, if you do it right, this will work every time, where the bracket will be the same. So we can pull out our bracket as a common factor, x plus 4, and then we're left multiplying that with our first term, 2x, and our second term, plus 3. Okay, so there's the answer. I notice it's different from factoring a simple trinomial, because when you factor a simple trinomial, your first term in each binomial is just 1, like x and x. That's not the case anymore. That's why it's trickier, a little bit trickier to do in your head, and decomposition is a good algorithm to follow to be able to figure that out. Right, so we're going to try B, C, and D. I'm going to let you try it. This will be the last thing we do today. And you can let me know if you have any questions.